What are the differences between igneous rocks and metamorphic rocks? Igneous rocks and metamorphic rocks are two of the three major types of rocks, with the third type being sedimentary rocks. While both igneous and metamorphic rocks are formed through processes of heat and pressure, there are significant differences between the two. Formation. Igneous rocks are formed by the cooling and solidification of molten magma or lava. Magma is the hot, molten rock that is found beneath the Earth's surface, while lava is the same material that has flowed out onto the surface. As magma or lava cools and solidifies, it forms igneous rocks. On the other hand, metamorphic rocks are formed by the transformation of existing rocks through heat and pressure. This means that a pre-existing rock, such as sedimentary or igneous rock, is subjected to high temperatures and pressure, causing its mineral composition, texture, and structure to change. These changes are often the result of tectonic activity, which can cause rocks to be pushed deep into the Earth's crust, where they are subjected to high temperatures and pressures. Texture. Igneous rocks have a crystalline texture that is determined by the rate of cooling. If the magma cools quickly, the crystals will be small, resulting in a fine-grained texture. If the magma cools slowly, the crystals will be larger, resulting in a coarse-grained texture. Igneous rocks can also have a glassy texture if they cool very quickly and do not have time to form crystals. Metamorphic rocks, on the other hand, can have a variety of textures, depending on the degree of metamorphism. The texture of a metamorphic rock is determined by the size and shape of its mineral grains. Foliated metamorphic rocks have a layered or banded texture, while non-foliated metamorphic rocks do not have a layered texture. Mineral composition. Igneous rocks are primarily composed of silicate minerals, which are the most common minerals in the Earth's crust. Some common silicate minerals found in igneous rocks include quartz, feldspar, mica, and amphibole. Metamorphic rocks can have a variety of mineral compositions, depending on the original rock and the degree of metamorphism. Metamorphic rocks can contain minerals such as quartz, feldspar, mica, and amphibole, as well as minerals that are not found in igneous rocks, such as garnet, staurolite, and kyanite. Origin. Igneous rocks are often associated with volcanic activity, such as the formation of a volcano or the eruption of lava. Igneous rocks can also be formed through the solidification of magma deep beneath the Earth's surface, where they are not associated with volcanic activity. Metamorphic rocks, on the other hand, are often associated with tectonic activity, such as the collision of two tectonic plates or the formation of a mountain range. Metamorphic rocks can also be formed through contact metamorphism, which occurs when rocks are heated by contact with magma. In conclusion, while both igneous and metamorphic rocks are formed through processes of heat and pressure, they have different origins, textures, and mineral compositions. Understanding these differences can help geologists better understand the geological history of an area and the processes that have shaped the Earth's surface over time. Do igneous and metamorphic rocks have a significant effect on earthquake formation? Both igneous and metamorphic rocks have a significant effect on earthquake formation. Earthquakes occur when the Earth's crust breaks and releases energy in the form of seismic waves, which can cause the ground to shake and damage buildings and infrastructure. The type of rock in an area can affect the likelihood and severity of earthquakes. Igneous rocks, for example, can be associated with volcanic activity, which can cause earthquakes. When magma rises to the Earth's surface, it can put pressure on the surrounding rocks, causing them to fracture and creating a pathway for seismic waves to travel. Additionally, the movement of magma underground can cause pressure changes that can trigger earthquakes. Metamorphic rocks can also play a role in earthquake formation. During the process of metamorphism, rocks are subjected to intense heat and pressure, which can cause them to become more brittle and susceptible to fracturing. This can make them more prone to earthquakes. The location of igneous and metamorphic rocks can also play a role in earthquake formation. For example, areas with large amounts of igneous and metamorphic rocks are often located along tectonic plate boundaries, where earthquakes are more common. These areas are also more likely to experience volcanic activity, which can further increase the likelihood of earthquakes. In addition, the properties of igneous and metamorphic rocks can affect the propagation of seismic waves during an earthquake. For example, the presence of fractured or porous rocks can cause seismic waves to reflect or scatter, leading to greater ground shaking and damage. Overall, the type, location, and properties of igneous and metamorphic rocks can all play a role in earthquake formation. By understanding these factors, geologists can better predict and prepare for earthquakes in areas where these rocks are present. Are igneous rocks or metamorphic rocks more resistant to earthquakes? Can you explain in detail? In general, metamorphic rocks are more resistant to earthquakes than igneous rocks. This is because metamorphic rocks are often more homogeneous and less fractured than igneous rocks, making them better able to withstand the stress and strain caused by seismic waves. Metamorphic rocks are formed through the process of metamorphism, which involves the alteration of existing rocks through heat and pressure. During this process, the mineral grains in the rock become more tightly packed together, which can make the rock more dense and less prone to fracturing. Additionally, metamorphic rocks often have a layered or banded texture, which can help distribute stress more evenly throughout the rock and reduce the likelihood of fractures. In contrast, igneous rocks are formed through the cooling and solidification of magma or lava. The rate at which magma cools can affect the size and distribution of the mineral grains in the rock, which can make it more prone to fracturing. Additionally, igneous rocks can contain a range of mineral types and may be more heterogeneous than metamorphic rocks, making them more prone to fractures along mineral boundaries. However, the specific properties of individual igneous and metamorphic rocks can also affect their resistance to earthquakes. For example, some types of igneous rocks, such as granite, can be particularly resistant to earthquakes due to their dense, interlocking mineral structure. In contrast, some types of metamorphic rocks, such as schist, can be more prone to fracturing due to their layered texture and the alignment of mineral grains along planes of weakness. The location of the rocks can also affect their resistance to earthquakes. For example, igneous rocks that are located near tectonic plate boundaries or active volcanoes may be more prone to fracturing and earthquakes due to the increased stress and pressure in these areas. Similarly, metamorphic rocks that are located in areas with high seismic activity may be more prone to fracturing and earthquakes. Overall, while metamorphic rocks are generally more resistant to earthquakes than igneous rocks, the specific properties of individual rocks and their location can also play a significant role in their resistance to earthquakes. Please don't forget to subscribe to my channel and turn on notifications.